Hey everybody, today we're just going to jump right into adding fractions with unlike denominators. So let's just quick review that in a basic fraction, we have the numerator, which is on top, and the denominator, which is on bottom. So when we want to add fractions together, we're going to especially be looking to make sure that the denominator is the same. And this gets tricky if we're given them, if we're given fractions that have unlike denominators. So let's jump right into that. Right, so our first example today is going to be 1 over 8 plus 3 over 4. So we can see right off the bat that they do not have the same denominator. One is an 8 and one is a 4. So our first step here is, how do we make them the same denominator? Is there a common multiplier that we could use? And in this case, we know that 8 is 4 times 2. Right? 4 plus 4 is 8. So let's adjust that accordingly. So let's keep going with 1 over 8 stays the same, plus 3 over 4. We're going to multiply that by 2 over 2. We can do this because 2 over 2 simplifies to 1. So we're not changing the value of the fraction. We're merely adjusting it so that it works better for our cases, and that we have an 8 in that denominator, which is we'll get from multiplying 4 by 2 right here. So continuing on, we have 1 over 8 plus, now we see 3 times 2 is going to be our numerator, so that's 6 with 4 times 2 in the bottom. So that is now 6 over 8, which makes sense. If you were given 6 out of 8 and asked to simplify it, you should be able to get that it is 3 over 4, just by dividing both the numerator and denominator by 2. So our last step is just, now that we have the denominators all settled out, all we have to do is add the numerators. So that means our denominator remains constant. It's still 8. And now we just have to worry about 1 plus 6, which will get us 7. So that's our answer for the first example. Let's just jump right into another one. This time we have 2 over 5 plus 1 over 10. And we have to find what that equals to. So once again, we have to think, how do we make the denominators the same? We can see that 5 does not equal 10. So how can we make them be the same? How can we relate 5 to 10? We do know that 5 times 2 is 10, so let's take advantage of that. Using the same idea we used in the last problem, we're going to multiply 2/5 by 2 over 2. 1 over 10 is the same as it was originally written. Once again, the 2 over 2 is simplified down to 1. So we're not changing the problem by doing this. We're merely scaling it so that the denominator is 10, so that we can add it. So looking at the numerator, 2 times 2 is 4. And now looking at the denominator, 2 times 5 is 10. And then we just have to add that to our 1/10. So what is 4 plus 1? I believe that is just 5. And then when we add fractions, we keep the denominator constant. So 5/10 is our final answer. We can take this a step further and think, is there a way that we can simplify 5/10 and reduce it? So both 5 and 10 are multiples of 5, so we can divide, sorry, that's not a 2. We can divide both the numerator and the denominator by 5, and that should get us 5 over 5 is 1, and 10 divided by 5 is 2. So our final answer is just going to be 1/2. And that would be our simplified answer. Your teacher might only just ask for basic answer, which would be this one. But if they ask you to have fully simplified answers, make sure that you can get it to 1/2 by dividing it by the common factor. So moving on to our next problem. Let's try 1/3 plus 4/9. All right, so how are 3 and 9 related to each other? How many times does 3 go into 9? It should just be 3 times. If we remember, 3, 6, 9, 3, 6, 9. So 3 times 3 would be 9, so we just want to multiply that first term by 3/3. And we can do 3/3 because that simplifies to 1, so it doesn't actually change the problem. And now we want to multiply this part. So we have 3 times 1 in the numerator is going to be 3, and 3 times 3 in the denominator is going to be 9, and we still have the 4/9 from the original problem. So now our denominator remains constant when we add fractions with like denominators, and we just have to worry about adding the numerator. So what's 3 plus 4? That'll be 7. So that was kind of a messy 7. That'll be 7. And there we are, finished with that problem. Here is another example. Let's go with 3/4 plus 2/12. So once again, right off the bat, we see that the denominators are not the same. So we have to first think, how do we relate 4 to 12? We know that 4 can go into 12 3 times, so we're going to want to use that as our multiplier. So we have 3/3 as our multiplier, which, just as a reminder, that is just equal to 1. Multiply that by 3/4, and we want to keep the 2/12 there. So multiplying this part of our equation, we have 3 times 3 is 9, and the denominator is 3 times 4, which is 12, which is exactly what we wanted to get the denominators the same. So now that the denominators are taken care of, we can just add the numerators together as we normally would. So 9 plus 2 would just be 11. So our final answer is 11/12. All right, for our final example today, we're going to do a slightly trickier version of this and look at 2/7 plus 1/3. Okay, so in all the other problems, we were pretty easily able to liken the two denominators through just one multiplier. But as far as I know, 3 does not go evenly into 7, so we have to be a little bit more creative with this and multiply both terms by a factor that's equivalent to 1. So because 3 and 7 do not fit so nicely into each other, we can say just multiply them and find the common multiplier that we're going for. What we want to see in the denominator is going to be 21, and that's our least common multiplier. So for our first term, 2/7, we're going to want to multiply that by 3/3, which, as a reminder, this is just equal to 1. And then for our 1/3, we're going to want to multiply that by 7/7, which is also just equal to 1. We are doing this way because both of these results will get us 21 in the denominator. So looking at the first term, we have 2 times 3 in the numerator, that's 6. 7 times 3 in the denominator, that's 21. And for the second term, we have 1 times 7, that's 7, over 3 times 7, that's 21. So we were still able to get the same denominator, even though it wasn't as easy easily obvious what denominator value to choose. So now that we have the same denominator available, we keep that constant, and we can finally just add the numerators like we would normally, which we'll get a, actually no, that's not 14, that's 13. So our final answer here is 13 over 21. I hope this video was helpful and that you guys feel a little bit better about adding fractions with unlike denominators.